Welcome to the lesson on 13.4, compound interest. How do you model the value of an investment that earns compound interest? So we're here to compare the simple and compound interest. There are two types of bond that sort of that exemplifies that. Conventional bond gives a coupon, an interest payment on a regular basis, but zero coupon bond does not give a coupon or simply interest payment. So what that means is that in a conventional bond, a simple interest, for $1,000 at the beginning of the year that you put, let's say you'll give you 5% of that money, and sometimes it's given to you once a year or divided up into twice a year. So you get $50 in interest, 5% of what you got, but at the end of the year you still have $1,000. So the following year you still begin with 1,000, you earn interest, you take it with you, but the amount that you put it in just remains the same, and that sort of continues on. So out of this you get $200 out of it, but you get the money $1,000 back. It sounds great and all, but if you put in a bond that, let's say, for lasts longer than 4 years, that $1,000 that you get back 4 years later is not worth the $1,000 the 4 years ago because of the inflation, right? So you have to keep that in mind. The second type is a zero coupon bond, whereas you put $822.70. Let's say its maturity date is 4 years and it pays 5% annual interest. You begin with $822.70. The interest earned is you multiply by 0.05. You get $41.14, but you don't get that. It just stays in its nest, and you add to what you have. You now have $863.84 at the end of the first year, of the 0 year. And then the next year, the year later, after you've put the money in, you begin with what you ended with, $863.84. You get 5% of that amount, not the original, but the ballooned amount, right? And you add to that, and you will end up with $907.03. And then you calculate 5% on that amount, which is $45.35. So you, at the end of the year, will have a total of $952.38. And that process continues. You get $1,000. So you had $822.70, but you get $1,000 at the end, right? So there are some advantages and disadvantages to each one. What works better for you is completely up to you. So let's talk about the math behind this. The equation for annual compounding annually is simply this. P is equal to 1 plus R raised to the T. V of T is the value of investment at the time T. P is the principal, the amount invested, and the annual interest rate. It is sometimes also known as APR, like annual interest rate, or sometimes it's called nominal interest rate. And time is T. So you need a calculator for this, guys. I use Desmo's logo, but that's for any graphing calculator. So you invested $2,000 in an account that pays 5% annually. When will that reach 10,000? Okay, put in your calculator. Actually, why don't you pause the video and you try. Welcome back. So if you put into the calculator, the first equation should be 2,000 times 1.05 to the x, because that's what that is right here. 1 plus the interest rate. The R is in decimal place, by the way. Okay, and then you want the second equation to be 10,000. When you graph it, this is what it looks like, and the intersection comes out to 32.986, so round up to 32.99, practically 33 years. Now the window that I use is I like to have negative value a little bit, and I didn't anticipate it going past 50, so I tried that. I don't like too many tick marks, so I did it every 5 years. I put the minimum as a negative 500. That way I have a little bit of space underneath. And then the maximum value is I want, which is 10,000, but I want that to be somewhere in the middle here. So I want my Y max to be a little bit higher than that. And I put the tick mark at every 500. Okay. If you didn't get the picture that I did, copy the window and let's go from there. And when you did that, the answer came out to 32.99 years by compounding once a year. Let's take a look at 2a, and this is a compounding more than once a year. And the equation is you divide the r, that's decimal value by the way, by number of compounding that's done per year. And the exponent, you have to calculate, let's say, twice the amount or 3 times the amount. So it's nt, right? Okay, put in the calculator and, okay guys, pause the video and you try. Okay, so when you plug it to the calculator, this is what it should look like. I didn't bother dividing out 0.05 by 2. I just left it as it is, just like the equation. And 2 is in the exponent, and x represents the time. And you trace it and find calculate the intersections, and I end up with, I believe, 32.59, right? I use the same exact window, so I could compare them actually, right? And it turns out to be 32.58 years by compounding twice a year. Now let's go back and compare that number to when you compound it once a year. What do you get? So you get 32.99 years compounding once a year with the same interest rate compounding twice a year. It only takes you 32.58 years. So it's a little shorter, right? So what that means is that your effective interest rate per year is slightly higher than 5%. Okay, and we'll talk about that once we get there. All right, let's talk about modeling interest rate compounded continuously. So what that basically means is that number of compounding per year essentially goes to infinity. There's some math involved. I won't do any derivations here in this class, but that equation that we had before, compounding per year, it becomes this, right? The math in the middle, if you're really interested, we'll go over in class. Oopsie, that should be n right there. I'm sorry, my apologies. That should be n. All right, so here's a question. $2,000, same 5%, compounded continuously. Find when the value of the investment reaches 10,000. Just as before, I typed in the interest rate, the equation, and I drew it. It came out to 32.19 years, right? Same window, guys. 32.19 years compounding continuously. Compared to the previous two results, I get once a year is 32.99, twice a year is 32.58, and by compounding continuously get 32.19. So more often you compound the interest rate, effectively speaking, you're paying more interest rate or getting more interest rate, right? And if you look at the back of your credit card, I believe it compounds daily. If you don't have a credit card, check out your parents. And that is the end of the video, and we'll pick up the rest in class. Have a good night.